Okay, the gimbal video is a bit more self-contained, I think, because there isn't that much kind of other stuff associated with it, at least in public. The gimbal video shows what looks like a little flying saucer type thing, and it's got this aura around it, and that was kind of reflected in the title of the New York Times article, "Glowing Auras and Black Money." But the aura was later discovered to be just kind of a standard artifact of the infrared camera system. It's this thing called an unsharp mask, which creates contrast in the boundaries between light and dark. And yet this was something that was promoted on the PTSA site, that there was an aura. On the New York Times thing, it was on unidentified. Why wasn't this discovered? If it's such a fairly simple thing that it's just an artifact of the camera. Even Jeremy Corbell now admits that it's just an artifact of the camera. Why wasn't this discovered right from the start?
Well, because I don't subscribe to that. I think you can look at something and say, oh, it's a artifact of the infrared and heat signature. But are you sure there was even a heat signature creating that? I mean, I don't know the physics, what creates that, and whether it is something naturally occurring or not. But there are other explanations. What you see on a camera, you can say, well, this explains that. Well, but there's other things that do too. And you're assuming that it had a heat signature, right? Because
what do you mean by a heat signature there? I think there's a lot of confusion as to what a heat signature means. So from your
infrared. So infrared in a technical perspective, you're looking at light wave energy below the visible spectrum of the red frequency, right? So infrared, which means below red. And you're usually typically dealing with that type of signature can be attributed to heat, right? Infrared. We use infrared cameras.
If you're getting a picture of something, aren't you getting a heat signature? It's an infrared camera. You can only see it if it has a heat signature.
Well, that's not true. What you see is contrasting in temperatures. It's not necessarily heat. You can also see with infrared cameras cold spots, which is the absence of heat. So my point being is that, we have to be very careful when we're looking at something. If we see something that fits a conventional model, well, okay, great. But I guess my word of advice to anybody, and this is including folks in the government as well, always look at the second and third order layers of data. It's important not to, and this is what we found in ATIP. In some cases, it would help us find conventional explanations. In other cases, it didn't. If you see something, an accident on the street, for example, you see two cars collide and one naturally assumes one car hit the other. Well, okay, it may appear that way, but you have to start, that's where the investigation really is important, that investigative process, to make sure you're not assuming or presuming something simply based upon looking at something in a video.
Sure. But, it's what it looks like to me. It looks like it is a glare of a heat signature, which would be like something like a jet. Like my broader hypothesis with this is that if you have a heat source, which I'm simulating here with a light source, and you shine it at a camera, then you get this glare around it, which is much bigger than the heat source. And we see this in videos of jets. The heat source covers the jet itself. It actually something that does actually happen.
It does happen. You're right. That's called lens flare. Yeah.
Well, that's not really lens flare. Lens flare is the reflection. No, this is lens flare over here. The reflection within the lens. This is glare. But your lens flare is creating a halo effect, if you will, from the object. And so a lot of people have said, well, this is an artifact of the camera, or this is lens flare, or this is an uneven distribution of light energy, as you say, from a heat source, creating this fuzziness, if you will, or this aura. But again, you have to understand temperature differences. You have to understand heat differences. You have to all those things to determine. And I have done a lot of research on this.